These questions are going to be similar to the kinds of questions that you'll see in the DBA for 2.09 and also those that you'll find during the test as well and in the practice test. So it's going to serve a lot of purposes here. Triangle cat is translated on the coordinate plane below or to the right really, to triangle C prime A prime T prime. Translate kite lion according to the same rule that translated triangle cat. So what I notice is that A, you go to the right 2 and up 3, T to the right 2 and up 3, and C to the right 2 and up 3. So we need to go to the right 2 and up 3 with all of our points here. So L to the right 2 up 3 is going to be here at 0, 5. That's going to be L prime. I to the right 2 up 3 is going to be right there at 3, 7. So 3, 7. That's going to be I prime. O to the right 2 up 3. It's going to be right here at 5, 5. That's O prime. N to the right 2 up 3. Right here at 3, 3. And that's N prime. Now we're going to connect those. And what I want to check once I connect them is making sure that it actually looks kind of the same as the other shape. And yeah, it does look like L-I-O-N, L prime, I prime, O prime, N prime. All right. Triangle UGH is translated using the rule xy goes to x minus 4, x plus 6. So that means we're moving to the left 4 and up 6 to create triangle U prime, G prime, H prime. What must be true about line segments drawn from the pre-image of each point to its image? So whenever we do a translation, every translation, what we can notice is that the lines that are drawn from a point to its translated point, all the lines are going to be parallel and the same length. And here's how to kind of see it. So if I look at this line that's taking A to A prime, C to C prime, T to T prime, they're all the same length and parallel. And so that really is the point here. So they are all the same length and parallel. Perform each series of transformations, mapping figure H to its image. What do you notice? So first we're going to do H prime and then also H double prime. So for this one, we're going to first go to the right 3, up 3. All right. So every point is going to go to the right 3 and up 3. So it's going to be here, 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 and there. And then reflected over the line y equals negative x plus 7. So y equals negative x plus 7. So I'm going to draw in that line. So at 6 and 7, that's the y-intercept right there. And then it's going to come down to 1, and then, oh no, 6 would be lower, sorry. So 6 would be about right here, and 7 would be about right there. So the slope is negative 1, so as we go to the right 1, we go down 1. And so here is where that line lies. Y equals negative x plus 7. The y-intercept is 7 and the slope is negative 1. So I'm going to draw in that line, and I guess I could have drawn in this little square. So that line came down like this, and Now, if we reflect across that line, what we notice is for this point, I move diagonally down and to the left one, and then down and to the left one more, puts it right there. Okay, so we're going to be right here. This point goes down to the left one, down to the left two, to get to the line of reflection. So we go down to the left one, down to the left two, and we land right there. Oh, this is interesting. Down to the left one, down to the left two. So down to the left one, down to the left two, right there again on top. And for this one, down to the left one, down to the left one, puts us right there. So that one lands right back on top of itself. Okay, that's interesting. So H prime is the same as H. Now we'll do H double prime. So we go here to the right 2 and down 2. To the right 2 and down 2 takes this point right there. And what you could, whoops, that's the wrong one, right there. What you could notice is if we're translating the whole shape, and this one goes over there, then the rest of the points have to look just like that. There's no way that they can't. So I'm just going to put those points in right now, and just go ahead and, whoops, sorry. There you go. That's an important thing for you to see. And go like this. And now we're going to reflect across the line y equals x plus 2. So y equals x plus 2 is this line right here. And so notice that this point goes up to the left 1, 2, and a half. 1, 2, and a half. So that reflects there. And 1, 2, and a half, and 1, 2. So it's not going to be the same. So H double prime, it's going to be up here a ways, kind of, and it's going to be off there. So that's hard to kind of see. H double prime is off the graph, off the grid, and not the same as H. All right, that's up. Trapezoid ABCD is rotated 270 degrees clockwise. What rule shows the input and output of the rotation, and what is the new coordinate of B prime? All right, so the first thing I think that might be useful to do here is to identify B as the coordinate -4, +3, because -4, +3. All right, so that's something that we need to do. The next thing, notice that if we go 270 degrees counterclockwise, right? 270 degrees clockwise. It's going this way 270 degrees. All right, so that's really the same as -90 degrees. And what happens when we do a negative, or we do a 90 counterclockwise, or 270 clockwise? They're the same transformation. And what it does is it takes a point, xy, well, let's just look at this point right here, -4, 3. It's going to go over here, and it goes to the X and the Y switch, And in this region, the x value and the y value are both negative. So negative 4, 3 will go to negative 3, negative 4. So notice that the x value moved into the y position and became negative, or excuse me, the y value moved into the x position and became negative. So this is going to be a negative y, and the x value here moved into the y position. And that is the rule for a 90 degrees counterclockwise, which is the same as a 270 clockwise degree rotation. Does the series of transformations carry the parallelogram onto itself? Reflection over the y-axis is our first one. Reflection over the y-axis. So I'm going to identify these transformations by color. Oops, didn't mean to go too far. So the first one is a reflection over the y-axis. So the y-axis is right here. So reflection over that is going to look like this. We need to, right there. This one, to get to the y-axis, we go to the right 1, 2, 3, 4. So we need to go to the right 1, 2, 3, 4. So it's going to be right there. Whoops. Here we go to the right 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, right there. And 1, 2, 1, 2, right there. So that is our first transformation. Then the next one is going to be a 90-degree counterclockwise rotation. Hey, that's the one we were just talking about. So we can actually take the points and just do exactly what we said. So it's the x and the y value switch positions, and the y value becomes negative. So might be useful to first identify all of the x and the y, identify these values, these points, 1, 3, 4, 3, 2, 1, 5, 1. So the x and the y switch positions, and the y value, when it moves into the x position, becomes negative. So this is going to become negative 3, 1. So negative 3, 1 is right there. This will be negative 3, 4. Negative 3, 4, right there. This will become negative 1, 2. Negative 1, 2, right there. And this will become negative 1, 5. Negative 1, 5, right there. Then we can connect those. And that is our first, or our second transformation. And the third transformation, let's do it in green. So that's just moving to the left 3. So every point will be moved to the left 3 units. So from here, 1, 2, 3. 1, 2, 3. So that's going to be negative 4, positive 2. 1, 2, 3. And last one right there. And we can connect those. And so that is our final transformation. Is the parallelogram carried onto itself? No. Describe the process for reflecting the point 4, negative 6 over the y-axis. So one way to think about this process is over the y-axis. So we count however many units. So if we maybe it'll be useful to draw it in here. 4, -6 is going to be down here. 4, -6. So what we need to do is count. We want to draw a line, or draw a line that will intersect with the line of reflection at a 90-degree angle. So we count in a way that we intersect at a 90-degree angle with the line of reflection. And however many units we had to count, we have to count that many in the same way the other way. So because we moved to the left 6 units to intersect at a 90-degree angle, we have to move to the left 6 more units on the other side of the y-axis. So we count, or let's say draw a line, I think. Draw a line that intersects the line of reflection at a 90-degree angle. Count the units. To the line. Sometimes you have to do a measurement there. You can't just count because it's at an angle. I will count diagonal units though, like I did earlier, and that actually works too. And then continue counting on the same line, however many units it took to get to the line. Six in this case. All right, using polygon ABCD at right, what transformation takes A to A prime, which is -2, 4, and D to D prime, -3, 2. So A goes to -2, 4, so -2, 4 is like right here. This is A prime, -2, 4. I think that they put this off of the graph on purpose. And D goes to -3, 2. D prime, excuse me. -3, 2 will be about right here. That's D prime. -3, 2. Well, this looked like it could have been a line, a reflection across this line. But notice that if it were, D would be here if it was a reflection. So it can't be a reflection. And so that means that it must be a translation because they both move to the left. 1, 2, 3, 4. 1, 2, 3, 4. So they both move to the left 4, and that's a translation. So translation, and let's just give the rule. It takes xy to x -4, that's to the left 4, but the y value stays the same. Ebony is cutting dough for pastries in her bakery. She needs all the pieces to be congruent triangles and has ensured that EF is congruent to ON, those line segments. So line segment EF is congruent to line segment ON. And angle MON is congruent to angle GEF. MON, this angle is congruent to angle GEF, that angle. All right, great. What would Ebony need to compare in order to make sure the triangles are congruent by angle, angle, side postulate? Angle, angle, side. So if you say this angle is congruent to that angle, be careful, that is angle, side, angle. Angle, side, angle. So it has to be that this angle and that angle are congruent, because then it's angle, angle, side. Angle, angle, side. So we need to show that angle G is congruent to angle M. Angle G is congruent to angle M. Which of the following is true if rectangle ABCD is congruent to rectangle EFGH? So what's really key here is that the parts are corresponding. So A corresponds to E, B corresponds to F, C corresponds to G, D corresponds to H. So the question is, are C and F, are those corresponding angles? So C is the third in the order, and F is the second in the order. So no, this is not true. EH is congruent to AD. EH, the first and the last in the line there, is congruent to AD. First and the last. Yeah, that one's true. Angle A is congruent to angle E. Yeah, they're the first in the order. They're corresponding, so they must be congruent. So corresponding parts are always congruent in corresponding shapes. And EF is congruent to A or BA. Oh, just a second. EF is congruent to BA. Oh, that's interesting because the parts are not in the right order. It seems like it should be AB, but it is the same line segment, so they are congruent. So that one's a little tricky, True, that one is congruent. Suppose that the measure of angle A is 72 degrees and triangle ABC is a right triangle. So we have a right triangle ABC, and A is a 72 degree angle. So it's not the, it's quite a bit bigger than the other one. So it needs to be like this, like that. So this is a 72 degree angle, and that is angle A. So which one is B and which one is C? What are the measures of angles B and C? How do you know? Well, it's one possibility is that this is B and this is C. And in that case, measure of angle B is equal to 90 degrees. It's the right angle. And the measure of angle C is equal to 18 degrees. And that is because our triangle must add up to 180 degrees. The interior angles must. All triangles have the sum of their angles is 180 degrees. Angle sum theorem. So by the angle sum theorem for triangles, so with the way I figured that out is 180 minus 72 degrees, 180 degrees minus 72 degrees minus 90 degrees equals the measure of angle C. And that then is 18 degrees. Now that's one possibility. The other possibility is that this is angle C and this is angle B. And in that case, measure of angle C is equal to 90 degrees, it's the right angle. And the measure of angle B is equal to 18 degrees for the same reason. Now, that is not all of this, the problems. That's not all of the problems, but it's a good long video. I hope that it was helpful, and I'll see if I can make another one for maybe the other half. I didn't want to make one so long. All right. See you in class.